Congrats! You have made it to problem 4 of the principle of addition and multiplication. So here, problem 4 is usually the hardest out of all 4 of them. So be sure to kind of refresh everything you learned from the other problems, and let's get started. So in a 7-digit number, there are only ones in or threes. So what that means is in this 7-digit number, you can have a mixture of ones and threes, or only ones, or only threes. So that's what the idea is trying to get. No threes are placed in the consecutive place values. So first, what does consecutive mean? Consecutive would mean next to, basically. So if this is white, colored, and these two next to it are uncolored, you would say the consecutive circles of this white circle are non-colored, consecutive. You can have consecutive integers, whole numbers, odd numbers, even numbers, so on. Now, how many 7-digit numbers apply to these conditions? So first, don't be afraid to go through a lot of process thinking. In number sense, you're often going to be faced with these different types of conditions, these different scenarios, and you just have to take your time to organize your thoughts and write down each of those observations from those scenarios. So let's first talk about if there are 7 ones. Well, if there are 7 ones, then every single one of those place values are a 1, right? So that would be only one. That would be one case. What about 6 ones? Well, as you can see here, 1, 2, 3, 4, 5, 6, 7. All right, we have a 7-digit number over here. If we have 6 ones, I guess we could do that. 6 ones, right? Wait, 1, 2, 3, 4, 5. 6 ones. There's only going to be one spot left over for 3. So you could choose any one of those spots, right? So that would be out of 7. 1, 2, 3, 4, 5, 6, 7. Right, so out of all 7 spots where this space can be, we're choosing out one place value to be that 3. So what this means is we can set the equation A71, which is equal to 7, right? So this is 7 cases. All right, it makes sense, right, that there are 7 different places that the 3 could be when there are 6 ones. If you don't get what A71 means, this is something very important. So I will be putting the link of the lesson that we covered this in previously in the description down below. So go down there and watch the video. If you don't get it, this is a hard subject. I don't blame you. So just keep trying and you can do it. Anyway, so this is 7 cases. Now let's move on to 5, 1. And as we're doing this, I'm just thinking, if no 3s are placed in consecutive place values, then basically we can't have 2 less ones. We need to have enough ones so that no 3s are next to each other. So what if we have 5 ones? That would mean there are 2 spaces left over. So if there's 2 spaces left over, then that would be out of 6 spots that this space can be, choose 2. That would be C62 because over here there's no order involved. So C62 is not the same thing, but it's related to A71. And we're going to have a section on this as well. Go down into the description if you don't know. And it's going to be equal to 15. So this is 15 cases. Now let's look at if there were 4 ones. Well, if there were 4 ones, then there would be less spots there would be more spots for the threes, right? So then that equation would be out of 5 possible spots for the threes, we need to choose 3 threes. We need to put in 3 threes. So that is equal to 10, meaning that this would be 10 cases. Now what about 3 ones? Well, 3 ones is the minimum, right? Because see, if you have 3 ones and no threes can be placed in consecutive place values, then this is the only way. 1, 2, 3, just like that, and the rest would be threes. But you can't switch any digits around, or else 2 threes would be next to each other, meaning that this is only one case. Only one case is possible. And if you have one less one, that wouldn't make sense either, because remember, if you take away a 1, it has to be replaced by a 3, and this does not make sense. So basically, after we have these different cases, we add them, right? So let's add. 1 plus 7 is 8, 8 plus 15 is 23, 23 plus 10 is 33, 33 plus 1 is equal to 34. So how many 7-digit numbers apply to these conditions? That would be 34 numbers.